Hello everyone, my name is Jesus Cantu, and today we'll be going over spectrophotometry, which is a quantitative analysis of light. Spectrophotometry involves the use of the electromagnetic spectrum. The electromagnetic spectrum consists of different wavelengths and energies ranging from radio waves, which are low in energy, to gamma rays, which are high in energy. The colors that we see on our daily basis are based on the interactions between light and matter. When light and matter interact at the right conditions, there's an energy transfer which causes the absorption or reflection of specific wavelengths, causing different colors that we're seeing. For instance, a material appears white because all of the colors are being reflected and none of them are being absorbed. Meanwhile, a material that appears black is absorbing all of the colors and not reflecting any of them. Therefore, wearing a black shirt on a hot summer day is ill-advised because it'll actually absorb more energy than a white shirt. In today's experiment, we will be studying the interactions of visible light with various multiple dyes, and when we do this type of study, we call it colorimetry. Now, when working in the lab, we can analyze our samples using multiple techniques. We can do qualitative analysis and quantitative analysis. Qualitative analysis primarily identifies your substance, while quantitative analysis gives us a direct measurement or quantity of your substance. So now that I went over some of the theory, we can move on to the experiment, which will encompass some of the principles that I went over about spectrophotometry. Before we move on to the experiment, we have to go over some safety precautions, and for that I have brought my friend Diego to help me illustrate what we have to be wearing throughout the experiment. First, we have to be wearing goggles, which he's wearing, and then we have to be wearing a lab coat, which is fully buttoned down. We have to be wearing gloves, because we're going to be handling chemicals, and then we have to have long pants. We should also be wearing closed-foot shoes so no chemicals fall into your feet, and if you have long hair, it should be tied back. Luckily, my friend has short hair, so he's fine.
Now that we're all safe, we can go ahead and begin our experiment. First, I'd like to go over some of the materials and reagents that we're going to be using in today's lab. On my right, we have the spectrophotometer, where you're going to be placing your samples with the reagents. You're going to use 2 graduated cylinders to measure out the volumes of the reagents for your solutions, as well as some beakers for handling of waste and solutions, as well as some matched vial sets. Now, making sure that these vials are matched is important because of the fact that you want to make sure that the spectrophotometer reads them identically. For our reagents, we're going to be using blue and yellow food coloring, as well as purple potassium permanganate. To begin today's experiment, we will begin by blanking our spectrophotometer. Blanking our spectrophotometer allows us to remove any interference from our solvent, or in this instance, our water that we're going to be mixing with our reagents. To do this, we'll go ahead and first take a DI water bottle, and we'll go ahead and fill our matching spectrophotometer vial. Now that our vial is filled, we can go head over to the spectrophotometer to blank it out. To begin the blank, we first need to make sure that the computer and the spectrophotometer are on and functional. To do that, for the computer, it's quite simple. Just check to see if your monitor is on and if the computer is on. You should see your desktop. From there, make sure that the microlab instrument is also functional and on. To do this, go ahead and check to see if the microlab LED is illuminated. If not, go ahead and press the green power button on the right-hand side of the microlab instrument and wait for the microlab to initiate and to illuminate the LED. Once that is done, go ahead and run over to your microlab application and double-click it to open it. This is going to take a couple of minutes as the instrument and the computer are talking to each other to make sure that the microlab is functioning and is zeroed out electronically. Once the microlab application is open, you're going to go ahead and go over to the spectrophotometer option under the main experiment type, and we're going to go ahead and click on that one. From there, you're going to choose spectrophotometric concentration, which deals with Beer's law, and the x-axis is going to be our concentration. We're going to go ahead and choose that one and click OK. This will take us to our spectrum profile, as well as the concentration graph, and give us some other information about starting the procedure. From there, we're going to take our light shield off. We're going to add our blank, which is filled with the deionized water that we put previously, and we're going to go ahead and add our light shield back onto the spectrophotometer. From there, it's as easy as going over to the read blank button and just pressing it. Now, this process is going to take a couple of minutes. You have to give time for the instrument to blank out the sample that we put in there and allow it to calibrate. For this time, it's a good idea to go over to your workstation and fill your solutions and mix them so that you can have your solutions prepared for part 1. While we wait for the spectrophotometer to blank, we can take this time to go ahead and make our solutions for part 1. To do this, we're going to need 3 vials, so let me go ahead and get some more. With these 3 vials, we're going to go ahead and make a solution of the individual colors on their own. One of the purple, one of the blue, and one of the yellow. We're going to add 1 drop of these and fill the rest with deionized water to make our solution. Now with these solutions made, we're ready to begin the part 1 of the experiment. So now that we have our blank red, we can go ahead and start with the beginning part of our first part of the experiment. We take our light shield off, go ahead and remove the blank that's in the spectrophotometer, and go ahead and place in our purple potassium permanganate sample. From there, we go ahead and click the Add button, labeling the sample ID as purple. The concentration or volume of this specific sample is not important at this time because we're just simply looking at the qualitative qualities or the identity of the potassium permanganate. So we can go ahead and leave that at 0. The instrument now will read the potassium permanganate sample and will provide us information on the spectral profile for potassium permanganate sample. As you can see here, currently we're in transmission on the screen. At the top, we see different buttons that allow us to change to absorbance, natural log of absorbance, the inverse of the absorbance, scattering and fluorescence, and backscatter. For this experiment, we're going to focus on the absorbance and the transmission. You can flip between these two to see the differences on the sample reading for potassium permanganate. Potassium permanganate reflects purple, and that's why we see purple, and it absorbs green, which is why on the absorption spectra, we see the 502 wavelength of green at high absorbance. While on the transmission spectrum, we see that the other colors are being reflected, and we see that the 395 and the 430 are the largest transmitting wavelengths that we see shown out on the screen. From there, we can go ahead and restart the program to begin with the mixing part of step 1. So now what we're going to do is we're going to go ahead and restart the microlab program and reblank our DI sample. I'm going to go ahead and take out the potassium permanganate sample that we had in there, and we're going to allow the machine to start up and initialize. This time, instead of spectrophotometer, we're going to go ahead over to color comparison. This application in the program is going to allow us to mix the colors without actually physically mixing them. It's going to take some of the information in the software that it has and theoretically combine the absorbances and the transmittance that it has to provide us with the color mixing without physically doing it. So we go ahead and choose the color comparison, and we're going to go ahead and do the reblank as we've done before, hitting the read blank button. Now we give a couple of minutes for this to finish. Now that our spectra is blanked out, our spectrophotometer is blanked, we can go ahead and add our different colors of our primary solutions to the machine and add them into the program. We're going to go ahead and take the light shield off, take our blank, and then go ahead and place our first sample, the purple potassium permanganate. Then we're going to go over to the Add button, click Add, and for the sample ID, we're going to hit purple, or type in purple. We're going to let the instrument go ahead and read it, and it's going to provide us a spectrum profile for the individual color of the potassium permanganate. Now that it's completed that, we're going to go ahead and take the purple sample out and add our yellow one, repeating the steps as before. Although this time, when we go ahead to we get to the sample ID, we're going to place yellow instead of purple. We're going to allow the spectrophotometer again to read our data, or read our sample. And once it's completed with that, we're going to go ahead and add our final solution of the blue color. Again, when we get to the sample ID, we're going to go ahead and place blue as the sample ID, allowing the instrument to read our final sample. So now that we have the colors ran and we have the information that the machine has provided for us, the spectrophotometer, we can go ahead and click on the Mix and Compare tab at the top of our screen. Now we want to show the mixing controls so we can show how much we're mixing of each color. but we want to go through the different variations to mix them to see what's going to come out for our spectral profile. Now, we can go ahead and mix our blue and our purple, and that will provide us a unique spectral profile of those two colors mixed. So we label it on the sample ID, blue and purple. So you can put blue ampersand P, or however you like it, however you'd like to label that out, so long as you know what colors are being mixed together. And then the machine will provide us a spectral profile of the colors blue and purple mixed together. You can also go to the absorbance to see what colors are being absorbed when those two colors are being mixed together. As well as you can mix the other colors together to see what different information you'll get provided for that mixing. Whenever you've done with these mixings, you're going to go ahead and go to your report sheet and you're going to copy the spectral profile for the mixings into your lab manual to provide as a report data for your experiment. So go through and mix the different colors that the lab manual dictates to mix and copy or draw the spectral profile for those individual mixings. For the second part of the experiment, we're going to go ahead and produce our solutions of the potassium permanganate with varying concentrations for the spectrophotometer. To do this, we're going to go ahead and take our bottle of DI and we're going to fill 4 beakers with 20 mils of deionized water. Now with the 4 beakers and the 20 mils in each beaker, we're going to go ahead and take our potassium permanganate solution and add the drops that are indicated by the experiment in our lab report. For this instance, I'm going to be placing half the amount of drops that is normally dictated by the experiment. Now we can go head over to our spectrophotometer and complete the second part of our experiment for the day. So now that we've finished with the calibration of our spectrophotometer, we can go ahead and add our pink potassium permanganate samples from concentrations of low to high. We start from low to high because this allows the instrument to read the values correctly. If we go from high to low, sometimes the instrument won't be able to read the values between samples as accurately if we go from low to high. So we start with the samples that we previously made of concentrations from the first, second, third, and fourth. We go ahead and take our shield off, remove our blank, and add our first concentration sample. This is denoted in the table that you see in your lab report as far as the concentrations and volumes are concerned. We're going to hit the add button, and on the sample ID we're going to hit 1, and for our concentration of volume we're going to put 1, since we're going to start with sample 1, 2, 3, and 4 as increasing in concentration. Let the spectrophotometer go ahead and read that data, and then we're going to start with the second one. So now that we have all the samples ran, you can see that the concentrations for the samples increase as we go through the samples, and our transmission decreases and our absorbance increases. What you want to do here is follow the guide behind the lab report, but basically you want to be looking at the transmission as well as the absorbance for this spectrum. You're going to have the concentration graph here that's going to provide you information about the different readings that you took through this part of the experiment. What you can do is you can go over to the Curve Fit tab at the top of your screen, and you can actually put, for absorbance, you can put linear, and for transmission, you can put quadratic. Now this will show you that the line is actually a quadratic for the transmission, which means that concentration is not proportional to transmission, while absorbance is. So if you look at the correlation coefficient for absorbance, we find that we have a very close correlation coefficient to 1, which allows us to accurately calculate concentration as it increases via the absorption that we get from the spectrophotometer. Now, from here, you're going to go ahead and answer the questions in your lab report to fill out the information that it's asked you to provide. As with anything in life, nothing is perfect, and sometimes things fail. Specifically, in speaking for this experiment, sometimes the spectrophotometers may not be working properly or might have not been initialized properly. So if you see that your samples are not reading correctly, such as when you put the potassium permanganate solution in, you expected to see no absorbance of purple, but you did see absorbance, then go ahead and speak to your TA, your professor, about this. They can help you troubleshoot your spectrophotometer and diagnose what the issue was whenever you perform the experiment. This concludes the experiment for today. We hope this helped you to understand the experiment a little bit better for the laboratory to come. If you have any questions, please talk to your TA or your professor.